So let's go ahead and graph in general the slope field that we see. And I'm just going along one of the lines that's kind of parallel to each other. What parent function does this look like from last year? Sine. And then let's look at the slope field on the next one. You could graph it wherever you want, but I want mine to go through the origin. So I think I see one that kind of does this. Does not have to be perfect. So which trig function does this remind you of? Tangent. And if I say it's not tangent, that's not the right way to put the x. It's tangent of x. And let's say I want something other than the trig function. What else does this look like? X to the power of 3. Now what really matters is the next page. So on the next page, we're going to find the slope field on every single point provided. So let's see. Okay, let's box dy over dx. So dy over dx is derivative, and specifically from unit 1. That is a slope function. So what I want you to do is make a t-chart with x, y, and m. And there's an easy way about going over this one, and a difficult way. We're going to use the easy way around. So let's analyze the original equation. If my numerator is 0, and I have 0 over any number, what would that result in no matter what? 0 over any number is 0. So what I want you to do on your slope field is the following. Wherever I see x equals 0, all of these, we're going to make a horizontal line. So x equals 0 is here, here, and here. And I'm skipping the origin for a reason. And I'll tell you why that is after we go over the y value. Let's say I have y equals 0 on every single one of them, no matter what the x is. What does it mean when you have a 0 in your fraction on the bottom? It is what? Undefined. And if you recall from Algebra 1, undefined graphs are vertical. So anywhere I see a 0 on the y, which is along the x-axis, let's make a vertical line all the way through. Now, if you care to write the next piece, you can. You don't have to. At the origin, when I plug it in, it's going to give me 0 over 0. And that's not undefined. That is indeterminate. Okay? Meaning we can't even graph it. All right? So if you're like, what happened? Because of 0 over 0. So let's move on to the next piece. For the others, let's say I have 1, 1. Let's all put 1, 1. And I plug in the 1 into the x on the top and the bottom. That's going to give us negative 1 over 1. Is that right? So that's going to be negative 1 slope. And we're just approximating what the slope looks like. So if yours is steeper than the other, it's okay. So with the partner, I want you to go ahead and draw the slope field for the rest of the dots provided on here. Go. Let me give you guys 1 minute with the neighbor.
Wait, so if it's positive, then it goes like that way?
Mm-hmm.
If it's negative, it goes down?
Yeah. And if it's steeper, you can make it more straight, closer to the vertical line. Okay, 1 minute. Help each other.
Just go 0, 1,
I hope you guys saw a pattern on the same number. 2, 2 is the same slope as negative 1, all the way down. Did anyone see that pattern? And then diagonally the other way is -1 all the way down. Then that way you don't have to plug it in manually. And you'll get closer and closer to making a curvature of a circle. Keith,
Is it just like it's the same
process.
same line in each box?
Mhm.
Right?
Yep.
Okay.
Although on this one, Keith, it's gonna be like a little bit steeper, right? And it gets steeper and steeper.
Oh, is that just for like the aesthetic?
Yeah. Mm-hmm.
Should I just?
I'll take it. So if your slope looks negative, but it's not too negative, that's okay, because we're just approximating. So mine's gonna get taller, and then it gets taller here. Less steep, more steep. Mm. So if my steepness looks a little bit different, that's okay, as long as you know if it's going in a positive or negative direction. All right, so now let's look at part A. The main thing I care about on this page is, can you draw the slope field? Part A and the last part, okay? So part A says sketch the solution through 0, 1. Let's put a dot at 0, 1. If I were to go along the slope field and make it include 0, 1, it's going to be closer and closer to a shape of a circle. It doesn't mean that's the only spot I can make a circle. I can make a circle wherever I want. So let's write on the bottom, it is a circle. What is the radius of the circle that I just made? Of 1. Now part B says, what about 0, -1? So when I plot 0, -1, isn't that part of the same circle?
Yes.
Okay, so I'm gonna write same circle. Oh, circle. Don't care about C and D. So let's move on to E. Do you guys remember the standard form of a circle from last year or even back in geometry? If you're like, I don't remember, here's our standard form. It is x squared plus y squared is equal to r squared. So is that circle possible using the slope field that we have above? Definitely, because it's an equation of a circle. Okay, on F. Max, let's read.
Which one?
F.
Solve the separable differential equation. Find the particular solution from point 0, 1.
So let's write the original equation that's given on the very top. It says dy over dx is equal to -x over y. So we're basically making y by itself. In the end, it's going to look like our standard form. So let's cross multiply. So when I do, I get y dy is equal to -x dx. And we want to make sure all the x's are together and all the y's are together. Is that the case for us? Yeah? How do I get rid of dy? Anti-derive, integral. So when I do, that's going to give me the following. Let's write the understood 1 so we can practice or re-practice integrating. 1 over, what is 1 more of that power? 2. Y squared is equal to, we have that understood -1 in front. What is 1 more of that current power? 2 again, x squared, and we need plus c. So what I can do at this point is plug in the x equals 0 and y equals 1. So I have 1/2 times 1 all squared is equal to -1/2 times 0 all squared plus c. So what is the value of c then? 1/2. So if I were to plug in the c value, it's going to give me the following. Half of y squared is equal to -1/2 x squared plus 1/2. Let's make this into a not so ugly fraction. What can I multiply everything by? 2. So that's gonna result in y squared is equal to negative x squared plus 1. Now I want this to look like the standard form. So when I add x squared on both sides, we have x squared plus y squared is equal to 1. Is that what we basically answered on part A? Yes, it is. Okay? So I showed you with the picture, and I kind of proved it to you by solving for y or putting it in a standard form.